right, so we're going to do derivatives of trig functions. Simple trig functions, that is. And for the sake of time, I'm just going to write these derivatives. If you're interested in seeing a derivation, I certainly can show you. But the derivations, they take a while, and they really don't help you memorize. So in reality, you just have to memorize. So the derivative of sine is cosine. The derivative of tangent is secant squared. The derivative of secant is secant tangent. Now notice when I say that, I say secant tangent, but when I write it, I write secant of x and tangent of x. So because your argument doesn't change, and you certainly have to write an argument with your trig function. So the derivative of cosine, and the reason I typed it this way, is that the derivative of cosine is, of all these c's, are negatives actually. So it's negative sine, negative cosecant squared, and negative cosecant cotangent. And for the purpose of this unit, all of our arguments are just going to be x or theta, whatever the variable is. Now we'll get into more complicated trig derivatives next unit, but this unit, pretty simple. The only thing I'm going to do is put a number in front. And so that number in front, if I have the derivative of 4 sine, my derivative is just going to be 4 cosine. The derivative of 2 cosine would be negative 2 sine. And yes, it is just that simple. So you love it. Let's look at this one. On the second example, how should you look at that tangent over 5? That's just 1/5 tangent. So, whoops, forgot the other c there. So cosecant of x, there we go. So the derivative would just be 1/5 secant squared. Careful, minus or plus. Cosecant, there's a minus, but since you add this minus, overall it's going to be plus cosecant cotangent. So the good news is these don't take you very long. Of course, I can put in things that don't have trig in with the trig, so secant would be secant tangent. And the derivative of 2x to the 4th is 8x cubed. The derivative of 3 is 0. And there you go. That's it. So it is a very pretty easy thing. Now with the thetas, again, don't get too confused. I'm going to write this down here so I have room to write it all in one line. So f prime of theta, the derivative of 8 cotangent is negative 8 cosecant squared. That theta cubed, don't get confused by that, because it's just like you look at that just like you look at the x. So plus 3 theta squared, and the derivative of negative sine of theta would be negative cosine of theta. And there are your derivatives. So not too bad. Not too bad at all. So let's look at this one. Write the equation of the tangent line to that function at 5 pi over 6. So once again, I'm just going to do that as I've done all the other problems. I need a point and I need a slope. So my point is going to be 6 times the sine of 5 pi over 6. I'm going to have to think about whether you do your chart or whatever. I'm going to think of it there. So the ordered pair is negative square root of 3 over 2, 1/2. Sine, of course, is the y. So 6 times 1/2, that gives me a value of 3. So my point is 5 pi over 6, comma 3. Now the slope, I'm going to find the derivative. So 6 cosine of x. And so f prime at 5 pi over 6 is going to be 6 times the cosine of 5 pi over 6, which is negative square root 3 over 2. So I have negative 3 square root of 3. So my final answer, it does say tangent line. Y minus 3 is equal to negative 3 square root of 3, x minus 5 pi over 6. So yes, you know, if your unit circle has left you, then you have to make sure that you get it back. Now this last one, it doesn't have trig in it, but certainly there will be some trig examples. I mean, I could have put trig in there. So you see that and you're like, what in the world is this? Well, these questions are very popular amongst AP. This is how they ask the definition of derivative questions. So I hope that you look at all of this and see that is the definition of derivative. That is the limit. Now they use delta x instead of h. They could use either one. As delta x go to 0, f of x plus delta x minus f of x all over delta x. So what is that equal to? Well, that whole thing is equal to f prime of x. So really the question is saying find f prime of x. That's the question. Then you just have to say, well, what is f of x then? Now you can do one of two things. I will tell you what I like. You have to be careful because this is minus f of x. A lot of people mess up on the signs. So I look at the front end and I just ignore the delta x's or the h's. So if I ignored those, I would have x to the 6th minus 4x cubed plus 2x. So this question, although I'm going to erase it so you see it in its entirety, this question is really saying to you, find the derivative of x to the 6th minus 4x cubed plus 2x. Now that's not a hard question. You know that answer. You say, well, it's this. And that's what that question is asking. So really, there's no f prime, but, I mean, it is f prime, but if the question is what is the limit, that is your answer. 6x to the 5th minus 12x squared plus 2. Now, it's not in your notes, but know that they could. If I would have changed all those x's, sometimes they ask you a derivative as a point. Remember we talked about if they fill in a specific value for all these x's, here, 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 and here, it could be asking you the specific derivative at a point. So you have to be careful. If it just has the x's in there, then your answer is going to be an equation. If your answer is a number, they either have numbers in for the x, or they say, well, let me erase that right now. They'll say, find the limit of this at x equals 1. They'll put the x kind of at the side. In other words, find the derivative at x equals 1. So if I would have changed the question to add that in, you certainly find that derivative, then you actually put in 1 for your x, and my answer would be a number. So 8 minus 12, that would be negative 4. So you just have to be able to read the question whether your answer is an equation or if they give you a value for x, they want the derivative at that specific point. All right, good luck.